Unit 910, relationships, are looking for relationships, and we're working away in box I here, where we are graphing linear relationships. And what do we want to be able to do at the end of this lesson? Exactly what it says there in the title. We want to be able to graph linear relationships. And the whole point of this section is to just give you some practice doing that. So let's just take a look at an example here. A carnival charges $10 admission plus $5 for each ride you go on. Can we find an equation that will tell us the total cost? Well, let's think first about what kind of variables we are working with in here. What sorts of things are changing in this question? Well, we've got the cost, okay? And what does the cost depend on? Well, it's going to depend on the number of rides that you go on, okay? So here we are, we've got cost depends on number of rides. So let's pick some variables to represent, pick some letters to represent our two variables here. I'm going to choose, let's use C for cost. So let C be cost. And then I'll let N be number of rides. Let's spell rides correctly here, R-I-D-E-S. Now, what is our equation going to look like? Well, we want an equation for cost. What does our cost depend on? Let's look at the information we're given in the question. Charges $10 admission plus $5 for each ride you go on. So no matter what, you're going to have to pay that $10 admission. So your cost is definitely going to be $10 plus $5 for every ride. Well, if N is the number of rides, the cost associated with those rides is 5 times the number of rides. So our equation here is that our total cost is 10 plus 5 times N. Now let's make a table of values and a graph. We want to find out if the relationship is linear or nonlinear. Well, let's do our table of values first here. We are going to put number of rides over here because it is our independent variable, and we're going to put cost in here, and we'll put a little dollar sign there because our units are dollars. And we're just going to pick some numbers here for the number of rides. Let's say we could go on 0, 2, 4, 6, 8, 10 rides. Okay? And for each of these values of number of rides, or N, we want to calculate the cost using this equation that we have up here. So for our first one, N equals 0, our cost is going to be 10 plus 5 times, well, let's just sub in our value of N. 5 times 0 is 0, so our cost is just going to be 10. And that makes sense. We'll pay the $10 admission and nothing else because we haven't gone on any rides. Next value of N is N equals 2. All right, let's sub that into our equation. 10 plus 5 times 2. Let's see. Do the multiplication first to get 10 plus 10. So our cost is going to be 20. Okay. And we could keep doing this. Our next N value is N equals 4. Cost is going to be 10 plus 5 times 4. 10 plus 5 times 4 is 20. 30. Okay? But maybe you're starting to see a little bit of a pattern here in this cost column. This is going up by 10. This is going up by 10. Okay, so you can sort of imagine that if we go on 2 more rides, we're going to add 10 more onto here. Then 2 more rides, add another $10. Another 2 rides, we add another $10. So that finishes off our table. Okay? Now we want to take the data from this table and we want to graph it. So let's see, we want our independent variable, number of rides, down at the bottom. And we want cost, up on the side. This has units of dollars. We always label our axes. And now we want to choose a scale. Okay, so we're going to start at 0 here. And I'm going to go over, for a number of rides, I'm going to say that each little box represents one ride. So I'm going to go over kind of like this. 2, 4, 6, 8, 10, 12, and so on and so on. Okay? And then vertically, I'm going to say that, oh, we can just say that each box represents $5. So 10, 20, 30, 40, 50, 60, 70, and that's probably far enough. And now let's plot these points here. Okay. Let's see, so when we went on 0 rides, it cost us $10. When we went on 2 rides, it cost us $20. 4 rides, it cost us $30. 6 rides, 40. 8 rides, $50 here. Make sure I got that one in the right spot. Nope, that's not in the right spot. I want it up a little bit higher. 8, we got to go all the way up to that 50 there. 10 was 60. Oh, 8. Sorry, 8 was 50, 10 was 60. Yep, and there we are. So, here we are. We've got you can see from the graph that this is a linear relationship. Okay, because if we wanted to, we could take our line here and draw a nice line of best fit that goes exactly through all of those points. Okay, so that's a little bit of practice working with linear relationships.